The interaction of two-point electric charge is described by a force with a magnitude proportional to 1 divided by r squared. We have already learned it in the last chapter. Molecular 1 and 1 and 2 for solid as an example. How the force between the molecules and their potential energy of interaction depend on the separation r, or the distance between them. If there are force between two molecules, what if the force always is a repulsion, which means the force always push the two molecules away from each other. In this case, if the solid consists of molecules like this, the force between molecules always push the molecules away from each other. Then, can or cannot the solid remain stable? Of course not. Of course not. If the molecules that consist of the solid always get away from each other, which means the volume of the solid should increase all the way, However, it is not what we know in our daily life. The shape or the volume of a solid always remains stable. Thus, the force between two molecules is not always repulsion, is not always as a state of repulsion. Then, assumption number 2. How about the force always show attraction? Which means the molecules that consist of the solid always attract each other. In this case, they will get closer and closer. And if the solid consists of molecules like this, the volume of it will remain to get smaller, which is also not what we know in our daily life. Therefore, the force is a variable one. The force is a variable one. And it has been drawn here. The force and the x-axis is a distance between two molecules. The y-axis is a force. You can see. Force and R. There is a stable place, R0. At this point, the force between them equals to zero. Then, if the R increases to R1, the force is a negative one, which means it is an attraction. Then, if the distance between them is smaller than the R0, the force is a positive one, and that is a repulsion. Which means no matter it is the distance between two molecules is larger than the R0 or smaller than the R0, the force Let's try to stretch it back to the R0. You can imagine like there is a spring that connects two molecules. No matter you push it away or you stretch it, you get closer. The force will try to make it back to the stable place for the R0. That's why in our daily life we always see that the solid will remain of stable volume because the distance between molecules that consist the solid always remain the same, and the distance between them always remain R0. Naturally, this is the electric force. The molecules consist of a nucleus, which is positive charge, and electrons around it, which is negative charge. When two molecules are close to each other, when they get closer than the R0, the repulsion between the two positive charged nuclei has a large force to make sure they won't get more close because too close to positive charged nuclei, the force between them is so large, the repulsion force is so large. Then, when they are little away from each other, the force between two nuclei becomes smaller. In this situation, the interaction is happening between the electron and the nucleus. Then it is attraction. Therefore, as you can see, when the two molecules are so close to each other, the force is so large. However, when they are away from each other, they will increase firstly and then decrease. Because the attraction between electrons and the nucleus in the middle or small volume, and the maximum of the attraction is only in a middle volume. However, the repulsion can be so large. Figure also shows the potential energy as a function of the distance. The potential energy can be learned. You can imagine the spring between them, and there is a potential energy in spring, also potential energy between molecules caused by the force. This function has a meaning at R. Where the force is 0, and the two curves are related by Fr are equals to dividing the d potential energy by dr. Such a potential energy functions often called a potential wave. A molecule at rest at a distance r0 from a second molecule will need an additional energy u0. The depth of the potential wave is scaled to a indefinitely large volume of R. Escape. What does an escape mean? The easiest example is the evaporation of water. Evaporation of water. The molecules first is the water. There are interactions between them. When the evaporated from the liquid to the gas, as we already know, the interaction between gas is so small and can be ignored, which means the molecules in the liquid get far away from each other. Before they're close and there are interaction between them. After the evaporation, they get away from each other and there is no interaction between them. In the microscope, there's the two molecules, and after the evaporation, they got away from each other. Or you can say they escape from each other. If before the evaporation, the two molecules are with a distance of r0. When they escape each other, the force always push them to be back to the r0, to be back to the stable place. Thus, energy is needed. To accomplish the escape of those two molecules. And how much the energy is the variation of the 0 by the U0, the potential energy. Or you can say the potential energy that need to break through the connection of the spring. Molecules are always in motion. Their kinetic energy usually increase with temperature. At very low temperatures, the average kinetic energy of a molecule may be much less than the depth of the potential well. The molecules then condense into a liquid or solid phase with average intermolecular spacing of about r0. That is before the evaporation. The distance between them is r0. Then, after the evaporation, they become gas, and the interaction between them can be ignored. The characteristics